Namaskar.
Hi,
Hi.
how are you doing?
All good. All good.
Okay, that's great. That's great. So I thought today we'll review Pythagorean theorem. Both of
Okay.
you have done Pythagorean theorem, right?
Not R, I don't think.
You're not done? Oh, then it's going to be very difficult for you. Okay, listen to that then. Yes. So there was, as far as the word problems are concerned and what we did about the cylinders and all those things, they are absolutely clear to you?
Yes.
No problem, right? Okay, great. So let me share the screen with you. Now you can see it, right?
Yes. Yeah.
Okay, so the title here is Pythagorean theorem. We are actually today doing a bit advanced level of Pythagorean theorem, but we'll try to keep it to basics. First, can you tell me what is Pythagorean theorem?
A squared plus B squared equals C squared.
So a right triangle, you should have a right angle triangle. Right angle triangle is the one which has one of the angles as 90 degrees, correct?
Yes.
So we'll go with the basics and one by one we'll pick up. So basically, if you read this, a right triangle has a right angle of 90 degrees as one of its angle. The
Yes.
side opposite to the right angle is called hypotenuse. R of, right? So if you have a right angle triangle, you understand right angle triangle? Do you see this 90 degrees here?
Yeah.
If I make this triangle, then we'll say OAP is a right angle triangle. Okay?
Yeah.
We have 90 degrees at A. So if you have one angle as 90 degrees, then it is a right angle triangle. Side opposite to A is OP, and that is called hypotenuse. Okay? Hypotenuse will be the longest side in any right angle triangle. The other two sides are smaller than hypotenuse, and we call them legs. Legs of a triangle. Okay?
Okay.
As Devansh was saying, these triangles are related. So we'll look into the relation of these triangles. The relation is that the hypotenuse square is equal to a square plus b square, the other two sides square. Okay? Now, Arav, look at this right angle triangle. There's only one triangle here, correct?
Yeah.
Where is the right angle? Can you tell me? C is the right angle, right?
Yeah.
That is the 90 degrees. And in triangles, we write side length as lowercase c, which is opposite to c. Opposite to A is A. Do you see how we write the length? And opposite
Yes.
to B, we have written B. Correct? So, which is the longest side? Tell me, Arav, which is the longest side of ABC?
B BCA like
Longest
the
side. BCA is the angle. Opposite to the angle is the side C, which is called the hypotenuse. And that is the longest side of a right angle triangle. Correct? And this longest side square is equal to sum of the squares of other two smaller sides. Clear?
yes.
What is area of a square? Can you tell me, Arav?
Uh
If A is the length of one side, what is the area of the square?
A cubed.
A
No.
square. A times A.
Squared.
A square. So, on A, if I make a square like this, area of this square is A square, right?
Yeah.
The square on the B side will have area of B square, and
Yeah.
square on the C side has area of C square. With this formula, we are trying to say that this big square area is equal to sum of the other two squares. Do you see that part?
Yeah.
Correct? So that is kind of important to understand. So squares on each side of the triangle are also related, just as the sides are related. Correct? Devansh, can you read what is written on this page?
You can visualize a right triangle with squares on each side. Area of the square is square of its side length.
Correct. Next para.
The area of the square on the hypotenuse is equal to the sum of the areas of the squares on the legs.
Correct. You understand both of you, right?
Yeah.
Now let's see how to prove this Pythagorean theorem. That is the difficult part. Most of the time, we only learn about Pythagorean theorem, right, Devans? Have you ever seen proof of Pythagorean theorem before?
No.
Not at all. So here is a very neat proof. You will be surprised to know that there are more than 300 proofs for Pythagorean theorem. So many people have proved Pythagorean theorem in so many different ways, right? Here is one way of proving it. Now, uh, Devansh, you know what is a plus b whole square equals to?
Sorry?
What is a plus b whole square equals to?
That's like the area of a.
Okay. So if I have this square, the big square, and I am dividing that into two lengths, one length is small a, the other length is small b, then the total length is a plus b, correct?
Yes.
So on this square, we have all the four sides of length a plus b. So the area of the big square will be a plus b whole square, right?
Yes.
Okay. On the other hand, what I've done here is I have connected these points and form a square inside. See, I have AB, 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 small triangles, correct? So each
Yes.
hypotenuse is going to be exactly same. Let that be C. In that case, the square will be formed inside the square, correct?
Yes.
Because each side is the hypotenuse, where one leg is A, other is B. So C is A square plus B square for each, right? So all these C's are of equal length, and therefore we have a square inside a square. Correct?
Yes.
What is the area of big square? It is combination of area of these four squares or four triangles
Yes.
plus the square inside. So if you add them all, you get area of the big square, right?
Yes.
Devansh, do you know area of a triangle is equal to what?
Yes. A plus B over 2.
Yeah, A times B, product,
A times. Yeah.
divide by 2. So that is what I've written here. Half of A times B is area of each square triangle, each small triangle, right? We have
Yes.
four of such triangles. So I'm multiplying that by 4, correct?
Yes.
Adding area of the square inside. Inside square is C square, area. Area of the square will be C square, right?
Yes.
So when I add that, I get the area of the big square. Perfect. Add them all,
Yes.
same area. So we have our equation a plus b whole square equals to 4 times half of AB, sum of these four triangles, plus C square. Now, you can simplify this 4 times half of AB, cancelling by 2, right?
Yes.
It becomes 2AB
Yes.
plus C square. On the left hand side, we have a plus b times a plus b. What is a plus b times a plus b?
It's the area of the large square.
But when you expand it, you know how to expand it, to multiply this?
Yes.
Okay. So if you expand, simplify, you'll get the term a square plus b square plus 2ab.
Yes.
Now, 2ab is on the left side and right side. Both of them will cancel, correct? We are solving this equation. They will cancel, correct?
Yes.
So you're left with a plus b, a square plus b square equals to c square, which is Pythagorean theorem. So if you consider that small triangle, in that case you can see sum of squares of a and b is c square, right?
Yes.
Do you understand this proof?
Yes.
Good. So Arav, for you, you don't have to understand the proof, but you have to understand the formula. If you have a right angle triangle, then always a square plus b square is c square. Is that clear?
Yeah.
Now, both of you know the formula. I will now give you 3 questions to do. Get ready with your paper and pen and copy the questions and do that. So we have, there you go. So we also have solution. Don't look at the solution. So come to
Yes.
this particular question, which is a right angle triangle. The sides are, hypotenuse is 5. It is very small, you cannot read it. But the hypotenuse is 5. And legs are 3 and x. Can you find x?
All right. Right. Where are the questions?
Okay, again write down. I'm not showing you the question because there is a solution also. So make a right angle triangle. The sides are 3 and x. For the smaller sides, hypotenuse is 5. What is
Yeah,
x?
I've solved that one. X equals 4.
X equals to 4. Very good. Bigger
Okay.
side is 13. Hypotenuse is 13. Smaller sides are 5 and x. How will you find x?
Right. For the second one, X equals to 12.
Very good answer. Third one. Copy this question, please. So we have a triangle ABC, which is the right angle triangle at A. The sides 4 and x are given to you for the big triangle. Then on the other side, we have ADC. Two sides are equal. AD and DC are equal to 1 each. So these two sides are 1, 1. You have to find hypotenuse x in this particular case.
All
Or
right.
copy the diagram. Then we will see the solution. Don't worry. We'll understand this today.
Yes. Double hypotenuse.
Yes. So we'll solve two triangles. Okay.
Yes.
Good.
Why do we have these? To indicate that they're the same size. Okay. Same.
That is right. So both are 1 each. 1, 1. You have to find the square root. So Arav, it is difficult for you. Just you sit and relax. Devansh, answer the question.
Yes.
You have done it?
Not yet.
Okay.
I just need to know square root of 2.
Just write square root of 2. Nothing else.
Okay.
When you square root of 2, it becomes 2, right?
Yes.
You can provide answer in square root. That is called exact answer.
I got x squared equals 18.
I think you're right. Good job. Now, Arav, you have to understand how your brother did all this. Okay? Devansh. Okay, do
Yes.
one thing for me. Arav, introduce yourself. In which grade are you and what are you doing there? Where are you from?
I'm in grade 6. Oh,
Where
yeah.
do you study? You're studying in a school in New Zealand, right?
Yeah.
Devansh, give me your introduction. So Arav is grade 6 student for us, okay? And Devansh is
Grade 8.
grade 8 student. You've done a great job for grade 8 student, mister. Now, Devansh, please explain the solution of solving the first right angle triangle whose sides are 3, x was unknown, and hypotenuse 5.
Yeah, so I wrote the equation 3 squared plus x squared equals 5 squared.
Correct?
And then 9 plus x squared equals 25.
Correct?
And then x squared equals 16, so x equals 4.
25 minus 9, and x
Yes.
equals the square root of 16, which is 4.
Yes.
Perfect. So, Arav, square root of 16 is 4. If you use the calculator, you will get that answer. 4 times 4 is 16. So, 4 square is 16. Square root of 16 is 4. That is how we see squares and square roots. Correct? Now, solution of the second one, please. Devansh.
5 squared plus x squared equals 13 squared.
Since these are the smaller sides, these are the legs. So their
Yes.
sum is equal to square sum is equal to the square of the hypotenuse, right? Then
Yes. 25 plus x squared equals 169.
yes,
X squared equals 144.
yes.
And x equals 12.
Square root of 144 is 12, right? 12 times 12 is 144. You got that answer. Now the last one. How did you solve this one?
So first I found the hypotenuse of the triangle ADC.
Correct.
So 1 squared plus 1 squared equals c squared. So c squared equals 2. 2,
Square root 2.
2,
Yeah, c is
yes,
square 2 and c is square root 2. Correct.
yes.
Yes.
So, and then I found the hypotenuse of triangle ABC.
Correct.
So 4 squared plus square root of 2 squared
Yes.
equals x squared.
Yes.
And then you can cancel out the square root because
Yes.
you've squared it. So 16 plus 2
Yes.
equals x squared.
18. Yes.
And yeah, x squared equals
Square
18.
root 18 is the answer.
Yeah.
Perfect job done.
I got that one.
Yes. You have understood, Arav?
Yeah, I got the last one.
Oh, good job.
Oh, nice.
Nice. So you have understood how to solve at least two right triangles side by side, right? If you could do
Yes.
two triangles side by side, you can solve any number of right triangles side by side, correct? This chain can continue and you can do many triangles. So I think you have understood this part. Now, you will notice that in your answers, here you got the number 3, 4, 5, right? These are all natural numbers. And in this case, you got the answer as 12, 13, and 5. Do you see that?
Yes.
All natural numbers. If for a right angle triangle, we get answers which have all natural numbers, then we call them triple. Pythagorean triple. We have a special name for it. So smallest triple is 3, 4, and 5. And then we have many. One of them is also 5, 12, 13. You notice one thing? 4 and 5, 12 and 13, difference is only of one number. Do you see that? 12, 13, and 4 and 5, correct?
Yes.
So difference is only one number. You will notice that all the triples, the difference between the hypotenuse and the longer of the shorter sides is only one, right? So we have a couple of ways of finding all the triples, which could be the sides of right angle triangle. So I'm going to share with you that particular formula today. So here is the formula. We know, can you read this? Set of natural numbers.
Yes. Set
What
of natural numbers. Yes.
What is natural number? Tell me.
A number that's not a decimal.
What are natural numbers? -3 is a natural number or no?
No.
Okay. Natural numbers are 1, 2, 3, 4, 5, 6, all positive, these numbers, right?
Yes.
If we include 0, they become a set of whole numbers, right? So natural numbers do not include 0, but when we include 0, it is called set of whole numbers. When we include negative and positive numbers, then they become integers, set of integers. And when you use decimal numbers, then we say real numbers. Is that clear to you?
Yes.
Okay. So set of natural numbers means numbers like 1, 2, 3, 4. If we have A, B, and C, just as we had 3, 4, and 5, or 5, 12, and 13, they are called Pythagorean triple. If A square plus B square is C square, right? So you'll find that there are some sets in which this condition is true. A square plus B square is equal to C square. Some of the examples are given here: 3, 4, and 5, 5, 12, 13, 7, 24, 25. You'll notice that the bigger of the two numbers, the difference is only one, correct?
Yes.
So we have a formula to calculate. You can keep this formula with you, so copy the formula. So smallest number will be 2n plus 1. Make a table like this, as shown here. Second column will be 2n square plus 2n. And in the third column, you add 1 to the second column. Do you see that?
Yes.
So, by putting different values of n, the natural numbers, starting with 1, 2, 3, 4, 5, and so on, you can get all the triples. So if I put n as 1, I get 3, 4, and 5. If I put 2, I get 5, 12, and 13. If I put 3, I get 7, 24, 25, and so on. So you can calculate about 10 triples like this. Another way to calculate triple is, if 3, 4, and 5 is a triple, then if you multiply each number by 2, for example, they become 6, 8, and 10. 6,
Yes.
8, and 10 will also be a triple, right? We enlarge the triangle 2 times. It is still a right angle triangle. You can enlarge it 3 times. 9, 12, and 15 will also be a triple. So all these triples which you get, they can be multiplied by some constant number and you get more triples. Do you see that?
Yes.
So that is how you can produce a set of triples. And it is very important to remember these triples, as knowing these triples, you can solve many triangles and many questions. Correct? You know, rectangle has a right angle, right? Square has a right angle. Most of the regular shapes, I mean, many shapes will include rectangles and squares to solve. Even square-based pyramids, right?
Yes.
And many other figures like prisms will have this kind of an end. So to find diagonals in such cases, we could use these triples straight away to get the answer. Very useful technique, correct?
Yes.
We'll end our chapter today by a few examples and the converse of Pythagorean theorem. The converse is like when we are saying that if we have a right angle triangle, then a square plus b square is c square. Now the other way is if a square plus b square is equal to c square, and these are the sides of a triangle, then the triangle is a right angle triangle, correct?
Yes.
Converse is also true. So can you please read what is written on the screen?
So if triangle has side lengths of A, B, and C units, and a squared plus b squared equals c squared, then the triangle formed will be a right triangle.
Clear, right?
Yes.
Now, based on this, we have an example. It's a multiple choice question for you. I'd like you to read the question and answer.
All right. C.
Right. How do you find it?
So it's the first triple.
Yes, the first triple. So once you know the triple, it is easy to match, right? One more idea, so that is a good way of doing it. And of course, you can confirm that 3 square plus 4 square is 5 square, right? Not a problem. Now here you need to explore. I'd like you to copy this particular triangle. The sides are, longest side is a square plus b square. And the other side BC is a square minus b square. And the smaller side is 2ab. So if you take two numbers, a and b, then with those two numbers, we can find the third side. You get the idea, right? Even all the three sides.
Yes.
So combination of two numbers could give you three sides of a triangle, a triple again. So this is another way of producing triples, just by guessing two numbers and then working on it, right? Well, in this case, it is not necessary that you will always get, in this case, you will get whole numbers when you're choosing whole numbers. But the idea is you could also take any real number for A, not only whole numbers, okay? What I'm trying to say is you can take A as 1.5 also if you want to, and produce the sides of the other lengths of the triangle. Is it okay? You could
Yes.
do that. So that triangle helps you in figuring out some related examples. Now here is a word problem. I would like you to read the question and then answer this particular question.
Anil drives at an average speed of 60 kilometers an hour to the office. If he drives north for an hour and then east for 90 minutes, find the shortest distance of his office from home.
How will you do it? Can you sketch a diagram for this?
Okay.
So sketch a diagram. I haven't done so. So first Anil is going north and then going east.
Yes.
North with this speed is same, 60 kilometers per hour. North he drives for 1 hour and east he drives for 90 minutes. Find both the distances and then the shortest distance will be the diagonal, right?
Yes.
Hypotenuse. Because north and east are at right angles, correct?
Yes.
So you have a right angle triangle. So you can find the distance between the starting point and the end point. So you have your
Yes.
diagram.
Yes, I've got it.
What are the side lengths? Tell me now of your diagram.
Right. So the first side going north is
Yes,
60
correct.
and the second side is 90.
You are right. And what is the hypotenuse then?
I'll just work it out.
That is true. You're on the right track. Arav, did you understand what is he doing?
Yeah.
Very good. So in grade 6, you're learning all this. That's a very good thing. You'll soon need it, okay?
Yeah.
Very good.
What do you need to do?
Yes, so you did square root of 90 square and 60 square. Did you get the answer, Devansh?
Yeah, I got 11,700 square root.
Square root. And when you use the calculator, it'll be 108.2. Check it.
All right. Just doing it.
No problems.
No, I actually put the same answer.
Good. So you are using calculator or you are using computer to find the calculations? Devansh,
I'm using the calculator on Google.
calculator on Google. Okay.
Yeah. Yeah, it's 108.2 rounded.
Right. Good job. So now I like you to take picture of the questions so that you could do them as a homework. Is that clear to you?
Yes.
We have three-dimensional cases here, and I like to take picture of this portion. You can take the whole picture also, verify your answer later. But take the picture of the question at least. So you're taking a snapshot, or how are you taking this picture?
I'm using Snip and Sketch.
Wow, very good, very good.
Yep, that's done.
Okay. And this picture. So that becomes your test question, okay? These
All
three,
right.
they are complicated. Three-dimensional figures. For grade 8 student, that is a very difficult question.
Yep, that's all done.
Perfect. So work on this and then post me the solutions. I'll also post you some related videos which you should watch. And also let me know topic of your interest for the next class. That'd be great. Okay.
All right.
If you have any topic in mind, just let me know. We can discuss that. Arav, for you also, we'll have a topic next time. Okay. Do you know about prime factorization, Arav?
Yeah.
You know how to find LCM and GCF?
Yeah.
You know how to use Venn diagrams to find LCM and GCF?
Yeah.
Okay, very good. Then you have to tell me what you want to do or what you want to learn in the next class. Okay?
Okay.
So post me, I'll prepare your lesson accordingly, and then we'll have a session next week, Friday. Is that clear?
Yeah.
Great. It was nice to have you both. Thanks a lot.
Thank you.
Thank you.